This is lesson 3.3, equations with variables on both sides. So we're still solving equations, but now it's getting a little more complicated. In this first example, they just want us to find the value of x. Well, we have this special diagram here, and the angles that are formed, when these two lines cross, we have 4 different angles that are formed. Here's 1, 2, 3, and 4. And what's special about these angles is the angles that are across from each other are called vertical angles, and they're always congruent. So this is just a little glimpse of geometry, but all this tells us is that this equals this. These angles are exactly the same. So I'm going to take them and set them equal. So I have 5x minus 3 equals 2x plus 12. And now we just need to solve like we've been solving all throughout Chapter 3. Before we can start solving for x, we need to get all of our x's on the same side. Notice here's our equal sign splitting it up into 2 different sides. We have 5x over here and 2x over here. So before we can start solving for x, we need to get all of our x's together in one place. And to do that, in order to cross this equal sign, to move 2x over here, to move 5x over here, we have to add, subtract, multiply, or divide. There are a couple things you can do. One, you could subtract 5x from both sides. Then, positive 5x, negative 5x would cancel. And then we get 2x minus 5x over here, which would give us negative 3, or negative 3x. I like to, though, stay away from negative numbers if at all possible. So, because that just cuts down on our steps that we have to do. So instead of subtracting 5x from both sides, why don't we subtract 2x from both sides? I like to always move my smaller variable term because that way I usually can avoid dealing with negatives. Now if we work it, or simplify, and by the way, this is just the subtraction property of equality. We just subtracted the exact same things from both sides. 5x minus 2x gives us 3x. Bring down the minus 3. Bring down your equals. 2x minus 2x, those are additive inverses. They cancel. And then bring down your 12. So all we had to do was move one of our x terms from one side to the other, because now this is just like every equation we've been solving. So we know we have to add or subtract first. So the opposite of a negative 3 or minus 3 is to add 3 to both sides. Negative 3 plus 3 cancels. They're additive inverses. Bring down 3x. Bring down your equal sign. 12 plus 3 is 15. And then it's 3 times x. The opposite of 3 times x is to divide both sides by 3. So we end up with x equals 5. And keep in mind that 3 divided by 3 is 1, and 1 times x is just x. That's why I canceled through the 3. So x is 5. Hopefully you remember that every time we solve, we can check to make sure our answer is correct by plugging in our answer for our variable. So we have 5 times 5 minus 3 equals 2 times 5 plus 12. Now on each side, we just need to follow PEMDAS. So 5 times 5 is 25 minus 3 equals 2 times 5 is 10 plus 12. 25 minus 3 is 22. 10 plus 12 is 22, and 22 does, in fact, equal 22. Therefore, we know that 5 is the number that will make the left side equal the right side. Let's try a few more. So again, we need all of our variables to be all together before we can start doing anything. We have negative 6b on this side, and we have a positive b on this side. So if I'm going to get rid of the negative 6b, the opposite of negative 6b would be to add 6b to both sides. And actually, I'm going to work this problem 2 different ways. So I'll first work it by adding 6b to both sides. Now, here's where people commonly make a mistake. They'll see negative 6b plus 6b, and they'll cancel it. But they won't put anything on this left side. Remember that you always have to have something on both sides of your equal sign. So if everything on the left side gets canceled, then you have to put a 0 as a placeholder. And sometimes people will just put their equal sign in some random place, or they get confused and they get stuck or whatever. But just keep in mind that you have to have something on each side. So if everything on one side cancels, then you have a 0. You need to put your 0 there as your placeholder. b plus 6b is 7b. Bring down the plus 4. And now we're just solving it. We want to move everything away from b. So the opposite of a positive 4 is to subtract 4 from both sides. 0 minus 4 is negative 4. Bring down the equals. Bring down your 7b. Plus 4 minus 4 cancels, additive inverses. And the opposite of 7 times b would be to divide both sides by 7. 7 divided by 7 is 1. And we can't do anything with negative 4 sevenths. I can't divide negative 4 by 7. I'll get a decimal. And we can't simplify it. We can't do anything with it. So our answer is simply negative 4 sevenths. Okay, let's try working that another way. So I have negative 6d equals d plus 4. The first time I added 6d to both sides, let's try it subtracting d from both sides, which we can also do because it really doesn't matter which variable you move as long as you work it correctly. So negative 6d minus another d, remember there's an imaginary 1 there. Keep in mind these have the same sign, so we add and keep the sign. 6 plus 1 is 7. They're both negative, so it's negative. Bring down your d equals d minus d cancels 4. And then how do we get d alone? Well, the opposite of negative 7 times d is to divide both sides by negative 7. Those cancel, so I have d equals negative 4 sevenths. Notice we got the exact same answer, but we moved different variable terms in each time. But as long as you do your math right, you can still get the same answer. Okay, in B, we've made it a little more challenging. Instead of just having to move our variables from side to side, we have to get rid of these parentheses first. We can't do anything until we have gotten rid of our parentheses. So we do that by using the distributive property. 2 times c is 2c. 2 times negative 6 is negative 12 equals 9c plus 2. Now this is like the last two problems we've done. So again, we need to get all of our variables on the same side. We can't combine like terms because we don't have any like terms on the left or any like terms on the right. So there are no like terms for us to combine. Instead, we've got to move. So I'm going to subtract the 2c since it's our smaller term. I'm going to subtract 2c from both sides. 2c minus 2c cancels. On the left side, we have a negative 12. Remember to keep the sign of whatever's in front of your term. Equals 9c minus 2c is 7c plus 2. The opposite of adding 2 would be to subtract 2 from both sides. These have the same sign, so add and keep the sign. Negative 14, bring down your equal sign. Bring down the 7c plus 2 minus 2 cancels. The opposite of 7 times c is to divide both sides by 7. So 7 divided by 7 is 1. Negative 14 divided by 7 is negative 2 equals c. And keep in mind that you can always plug in your answer for your variable to check it. Couple more. C is not as complicated. Again, we just have variables on both sides of our equal sign. We need them all on the same side. So I always like to move the smaller one. M is smaller. The opposite of a positive m is to subtract m from both sides. M minus m is 0. 0 minus 5 is negative 5. Bring down your negative 5. Bring down your equal. 3m minus an m, and remember this is minus a 1m, so 3 minus 1 is 2. 3m minus 1m is 2m. The opposite of 2 times m is to divide both sides by 2. That cancels, and I have negative 5 halves. Now this is an improper fraction. It's not going to divide evenly, but it is an improper fraction, so I can change it into a mixed number. Since I have a negative number divided by a positive number, I know I'm going to end up with a negative. 2 goes into 5 2 times. 2 times 2 is 4, so there's 1 left over. Negative 2 and 1/2 equals m. And last one of these that we'll do, again, we have k's on the left side, k's on the right side. We have no like terms to combine on either side. Instead, we have to add or subtract to get our variables from one side to the other. So looking at 5k, it's my smaller one. It's positive, so the opposite of positive 5k is to subtract 5k from both sides. 7k minus 5k is 2k minus 4 equals 5k minus 5k is 0, 16. The opposite of subtracting 4 is to add 4 to both sides. So we have 2k equals 16 plus 4 is 20. The opposite of 2 times k is to divide both sides by 2, so that k equals 10. Okay, let's look at a word problem now. It says you can buy a skateboard for $60 from a friend and rent the safety equipment for $1.50 per hour. Or you can rent all items you need for $5.50 per hour. For how many hours must you use the skateboard to justify buying your friend's skateboard? So let's go through and mark out or highlight the important things. One thing is you can buy the skateboard for $60 and rent the safety equipment for $1.50 per hour. Or, so this is one situation. You buy the skateboard and you rent the safety equipment for $1.50 an hour. Or you don't buy the skateboard and you just rent everything for $5.50 per hour. And they want to know for how many hours. Remember that in the question, they tell you exactly what you're trying to find. If we're trying to find it, we don't know it. If we don't know it, it's a variable. So they're giving us the variable here, for how many hours. So I'm going to use H as number of hours. And in this one situation, we're going to pay $60 and $1.50 per hour, so that's times H. And then we want to know for how many hours must you use the skateboard to justify buying your friend's skateboard. So for how many hours, we'll set it up as equal, and then we'll know when the two situations are exactly equal, when we will have paid the exact same amount. And so then we can determine how many hours we have to use it to buy it. So this is the first situation, $60 for the skateboard. Sorry about that, plus $1.50 per hour. And then the other situation is just $5.50 per hour. So that's the hardest part of setting up the equation. Once you've done that, all we're doing here is solving, and we're solving just like we did in example 1. We have H on the left side, H on the right side. We need them all on the same side. So move the smaller one, the opposite of a positive $1.58, or 1 and 50/100 H is to subtract 1 and 50/100 H from both sides. So we bring down the 60, plus 1 and 50/100 H minus 1 and 50/100 H, that cancels. Bring down your equal sign. 5 and 50/100 H minus 1 and 50/100 H. The zeros cancel. 5 minus 5 is 0. 5 minus 1 is 4, so it's 4H. And then we divide both sides by 4 to get H alone. 60 divided by 4 is 15 equals H. So this just tells us that after 15 hours, these two will be exactly the same. The cost will be exactly the same. So if we use it more than 15 hours, we know that our hours are going to cost less, so we should buy the skateboard if we're going to use it for more than 15 hours. So our answer then is, because they asked how many hours would you have to use it to justify buying it, the answer then is more than 15 hours would justify buying it. Because after 15 hours, they won't be equal anymore. It'll cost us more to rent everything than it will to have just bought it. Okay, here's example 3 that asks us to solve, but there's something special about example 3. They're not just asking you to solve, they ask you to solve with a graphing calculator. So I'm going to pull up a little application online, a graphing calculator online that's similar to a graphing calculator you would use in class, but it's not exactly the same. But hopefully you'll get the gist. So we want to know, when does the left side equal the right side? For what value does x have to be? So for what number does x have to be in order for the left side to equal the right side? So we're going to use our graphing calculator to put in these two different equations. Okay, so the first equation then, if you remember, was 2 and 5/10 x plus 1. So 2 and 5/10 x, oops, that's not our x, sorry, that's the multiplication sign, x plus 1. The other equation we'll type in the second y equals line. So if you're on your own graphing calculator, you're using the y equals button and inputting two different equations. The other equation was 4x minus 2.6, or 2 and 6/10. Okay, so we're going to tell it to graph. Great. And then we want to know, for what value of x do these two equations equal each other? So that's right where they cross. That's what we want to know. Because, again, we're trying to figure out, where does the left side equal the right side? So if they're going to equal each other, it's going to be, where's that one place where they're exactly the same thing? Where's that one place that both of these lines have the exact same point? So to do that on your calculator, you would go to the second calc button, calculate, and you would calculate the intersection, which is number 5. So we're going to ask it to calculate the intersection of these. And on your calculator, you just press enter a bunch of times. But on here, we press find the intersection. And the intersection is 2 and 4/10 and 7. So that means that This point here is over 2 4/10 and up 7. Therefore, x is 2 4/10. For the x value of 2 4/10, these two lines will be the exact same thing. The lines will equal each other. So then that's our answer. Our answer is 2 4/10. And look, we didn't even have to solve. That's the answer. But I'll show you how it really does come out to give us the answer. Remember that you can multiply both sides to clear the decimals. Since the largest place is the tenths place, I'll just multiply both sides by 10. And then you have to distribute because everything has to be multiplied by 10. So we're moving this decimal one place, 25x. Move this decimal one place, that becomes plus 10 equals, again, this decimal one place, so 40x minus, and then move that one place, 26. And now we can solve. We need all our x's on the same side. Minus 25x minus 25x. Move the smaller one. So we have 10 equals 40x minus 25x is 15x minus 26 plus 26 plus 26 gives us 36 equals 15x. That cancels. Divide both sides by 15. And x equals, let's see, 15 goes into 36 two times. That gives us 30. So we have 6/15. And then, of course, we can simplify. So we have 2 and. If we divide top and bottom by, let's see, 3, then we get 2/5. And, of course, we could multiply top and bottom by 2 and get 2 4/10, which would be 2 4/10, which is exactly what we got. So see, using your calculator, you can spare yourself all that work, or you can check the work you've done. So the steps are to go to your y equals button and type in the two equations. And then you're going to graph. And then you hit the second calc button. And you go down to number 5, which is intersection or intersect. And then you just press enter 3 times because it'll keep saying, first curve, second curve, guess, and then it'll finally give you the answer. Okay, so here's one more that you use the graphing calculator for. And again, you just take this left side and it's one equation and the right side is another equation. So I'll show you that one more time using that graphing calculator on here. So we need to go back to our equations and clear these and type in our new equations. So the first one was 4 plus 1/2 x, 4 plus 1 divided by 2x. So if you're trying to put in a fraction, 1/2 would be typed in as 1 divided by 2. The other is simply x minus 1. There's an easier one, x minus 1. And we want to graph it. Okay, so there's our two equations. You can't see it real well. Let me zoom out a little bit. There's our intersection. So you can see we want to know where do these meet, because that tells us that's the only place where these two lines are exactly the same. And that's what we want to know. So we want to know the intersection of both of our lines. Find the intersection, and it's over 10 up 9. Over 10 up 9. Therefore, the x value is 10. For the x value of 10, that's where these two lines will be exactly the same. So our answer there is just 10. X equals 10. And that was much quicker than solving it. But again, let me show you how to solve it. If we were to solve it, we need all of our x's on the same side. You can multiply to clear the fraction, or you can leave it in there if you want. So this is the smaller one, so I'll subtract 1/2 x from both sides. Bring down your 4. These cancel. Equal. This is, again, a 1x. So 1 minus 1/2 leaves us with just 1/2 x minus 1. And then we need to add 1 to both sides. So 4 plus 1 is 5 equals, bring down your 1/2 x. Negative 1 plus 1 cancels. What's the opposite of 1/2 x? Multiplying both sides by 2. You have to do it to both sides. So 2 times 5 is 10 equals 1/2 times 2, or half of 2 is just 1, times x is x. And you can see either way, working it out mathematically or putting it in our calculator, we get x is 10. All right, let's look at example 4, our very last example. And before that, we had the vocabulary word identity. So let me go ahead and split that in here. And identity is an equation that is true for every value of the variable. So let me give you an example of something that's not an identity. How about like x or 2x plus 7 equals 18 or 19. 2x plus 7 equals 19. So let's solve this. So we would subtract 7 from both sides. Bring down the 2x. Bring down your equals. 19 minus 7 is 12. Divide both sides by 2. And x equals 6. Remember that what this answer means is that 6 is the only number you could plug in for x where the left side would equal the right side. So let's check it. 2 times 6 plus 7 equals 19. 2 times 6 is 12, plus 7 is 19. 12 plus 7 is 19. 19 does equal 19. So that's what our answer says. Well, let's try another number. What if we tried, instead of 6, let's try 2. So 2 times 2 plus 7 equals 19. Is that true? 2 times 2 is 4, plus 7 equals 19. 4 plus 7 is 11. Does 11 equal 19? No, it does not. And the reason the left side doesn't equal the right side is because 2 doesn't work for this equation. The only number that will make the left side equal to the right side is 6. That's why when we solved our equation, we ended up with the number 6, because that's the only number you could put in for x where the left side would equal the right side. Well, an identity is special, because what an identity is where any number you choose will be the same for the left side and the right side. Any number you choose will work to make the two sides equal. So let me give you an example of an identity. How about 2 times the quantity x plus 4? And that would be, so here's our identity equation. Let's go ahead and solve our identity. So we'd have to distribute first. 2 times x is 2x. 2 times 4 is 8, so plus 8 equals 2x plus 8. Hopefully you see right here, well, yeah, the left side equals the right side. But let's go ahead and solve it and see what happens. So if I subtract 2x from both sides, 2x minus 2x cancels, 2x minus 2x cancels, all of our x's are gone, and we're left with simply 8 equals 8. Well, yeah, 8 equals 8. When you get something crazy like this, we didn't end up with x is 7, x is 4, x is 2. We ended up with 8 equals 8. And the reason we didn't come up with something like x equals negative 5 is because there isn't just one number that you could use for x. You could use any number that you could ever think of for x, and the left side would equal the right side. So let's choose a random number. How about 3? Let's try 3. So I have 2 times the quantity, 3 plus 4, equals 2 times 3 plus 8. So we can follow PEMDAS. 3 plus 4 is 7, so that's 2 times 7 equals, again, following PEMDAS, 2 times 3 is 6 plus 8. 2 times 7 is 14, and 6 plus 8 is 14. Yeah, so they equal each other. Remember what happened up here when we just tried some random number? We got 11 equals 19, which is so not true. But with an identity, any random number you pick will work to make the left side equal the right side. That's what's special about an identity. So again, for just any old regular equation, you'll end up with something like x equals 6 or y equals 15 or whatever. But when it's a special equation like an identity, you won't even find an answer for x. You won't end up with x equals anything, because there isn't just one number that x can be. It can be any number you could ever think of. It has an infinite number of answers. So by the way, the answer on this equation would be simply identity. When you write that, it tells people that any value you choose for x will work to make the left side equal to the right side. In this equation, there's only one value. There's only one answer. Only 6 will satisfy this equation, but not in the identity. Any value will satisfy the equation. So let's look at a couple more identities, or a couple more equations. So again, we're just going to solve. We have to start by distributing. We have to get rid of the parentheses first. I'm leaving the left side alone. Bring it down. 4 minus 4y equals negative 2 times 2y, negative 4y, negative 2 times negative 2 plus 4. And now you know we have to get all of our variables on the same side before we can do anything. So we have negative 4y. The opposite of a negative 4y is to add 4y to both sides. And then what do we end up with? Bring down your 4. Negative 4y plus 4y, that cancels. Bring down your equals. Negative 4y plus 4y, again, it cancels. And we bring down our 4. So, again, we didn't just get an answer for y. We didn't just get some random answer. What we found is that this problem is an identity. Yes, 4 does equal 4. And what that tells us is that any number you could ever choose for y would make the left side equal the right side. So let's look at B. On B, we have to combine like terms before we can even start moving our variables. Notice that's something we want to check for. No like terms on the left side, but we do have like terms on the right side. So we want to combine those first before we start moving our variables. So I have negative 6z plus 8 equals z, and negative 7z gives us negative 6z plus 10. And now we need to get all our variables on the same side. So the opposite of a negative 6z is to add 6z to both sides. So we get negative 6z plus 6z cancels, bring down your 8, equals negative 6z plus 6z cancels, bring down your 10. But what is this? We didn't get 8 equals 8, or 10 equals 10, or 4 equals 4. We got 8 equals 10. And does 8 equal 10? No. 8 does not equal 10. These kind of problems mean that there is absolutely no solution. There is no number that you could ever come up with that would make this left side of the equation equal the right side of the equation. There is absolutely no number in the whole world that would satisfy this equation. So now we've learned about 3 different types of equations. The first type is just what we've been working on since the beginning of Chapter 3, where you solve it and you get an answer. It has one answer. There's only one number that works for the equation. The second type is an identity, where any number you could ever think of would work for the equation, would make the left side equal the right side. And you know it's an identity when you end up with something like 4 equals 4, where you don't end up with x equals something or y equals something. You just end up with a number equals itself. That's an identity. But when you end up with a number equals a different number, that tells you that there is no number that could satisfy the equation. There's no number that would make the left side equal the right side. So that answer is no solution. Again, we have 3 different types of answers. A single number by itself, identity, or no solution. So let's look at 2 more together. So here we have no like terms to combine on either side. We don't have parentheses to contend with. All we need to do is get all our variables on the same side. So the opposite of a positive 5n is a negative 5n. Cancels. 9 equals cancels. Negative 1. Is that true? Nope. No solution. Let's try B. So on the left side, no like terms. On the right side, we have 7x and negative 2x. So we need to combine like terms first. Bring down 9 plus 5x equals 7x minus 2x is 5x plus 9. And then we need to get all our variables on the same side. So the opposite of a positive 5x is to subtract 5x from both sides. So I end up with 9 equals 9. Is that true? Yes, it is. That means it's an identity. And again, all that means is that no matter what number you plug in for x, it will always satisfy the equation. The left side will always equal the right side. Good luck.